Today we will discuss about all the layers present in the CNN. So let's start via convolution layer because it is our first layer, we can say. So this layer is first layer we used here to unshape the numerous attributes from the input object. Input we can say anything like image, text, speech, etc. So we need to collect the information from our data sets so that we reach the desirable output, right? So in this layer we apply mathematical operation of convolution, which is performed in between input image and filter having particular size, as we can say x cross x, or we can take example as a 3 cross 3. Anything means filter is must have to be lesser than the input. Now while sliding the filter across the input image, we will take the dot products of filter and the input image with respect to the size of the filter that we have taken 3 cross 3 in the figure. So the output is termed as the feature map that provides the particular of images such as corner and edges. In a while that activation map is fed to further layers to learn various different features of input image. Now, one question arises in my mind: how many filters does CNN generally use? Means, is there having any criteria? So let's discuss CNN unable to grasp from a unifilter as it passes through the multiple layers of filter side by side for the designated input. For example, mainly 32 to 512 filters were used in parallel to take the knowledge via convolution layer. So now we come to the fully connected layer. As we have earlier studied it, but for understanding it in a better way, we have to understand it. No worries. Now let's come to the point. What is fully connected layer? We can call it as a FC also. So a fully connected layer is finally the last layer of the, no, I can't say it last because I think activation function is the last layer. So of CNN, so which is also called the dense layer. So the portrait that feature map acquired from the preceding layers to the ultimate output classes. The output consists of vector of echelon outcome accompanied by one outcome from each echelon. Right, so the formula it is uses, you're saying yi is equal to f of summation j to j. As here j to j, why I am writing because I am able to write it j1 to 5 or 1 to 6 or 1 to 10, so that's why I hope it is understood. Now wij can be anything 1 to 5, 1 to 10 or whatever digit we have taken, and then xj. So here summation 1 to 5 we have taken 5 inputs neurons, then like x1, x2, x3, x4, x5, and 3 output neurons. So yeah, y1, y2, y3. So before going to, I mean, before going to next slide, we can understand it in a better way. I think it is very important. So fully connected layer consists of voice and biases along with the neurons and used to connect the neurons between two matrices. In other way, we can say FCA, also known as a line or layers that connected to each input to each output neuron, are commonly used in neural networks. Right. So neural network are set of dependent non-linear function. Each individual function consists of neuron or perceptron. Okay. So in fully connected layers, neurons applies a linear transformation to the input vector through weight matrix. Right. Uh, Nonlinear transformation and then applied to the product through a nonlinear activation function. So activation function, that is f. There we are taking the dot product between vectors input, we can say product between weights matrix w and the input vector x. The bias term w naught can be added inside the nonlinear function, as you're seeing in the figure. That function I'm talking about, that is yi is equal to f of summation j to j, that is 1 to 5 anything, or wij or xj, right? So here that w stands for matrix, it is weight matrix, right? It stands for weight matrix, and then xj is the input vector, right? So let us consider we have 5 inputs and 3 output, right? So the detailing we will talk in the next slide, please. Yeah, so here it is showing the in violet color or dark input x1, x2, x3, x4 or x5, then output be y1, y2 and y3. You can see how each input is connected to output. Yeah. First one is connected to all three, and then second input is connected to all three, and then third input is connected to all three. It is like family member. Like in our family, if we have 4 members or 5 members, each member is connected to each other, right? So it is similarly like here, it is connected to each one. So we can say even output is also connected to each layer of the input. Yes, same. So n cross m weights each pair wij. Let us consider we have 5 input neurons and 3 output neurons. As you're seeing, input in x terms and y in output is y terms. In fully connected layer, we apply weighted linear transformation to the input neurons and then pass the output through the nonlinear activation function. So the formula for computing value for output layer will formed as I've explained. So as we know that an image composed of smaller details of feature, a fully connected layer in CNN is the one which takes the final results of convolution or pooling via flattened layer and conclude the classification decision. Right, means in actual it serves the actual purpose of classification. Without fully connected layer, conventional layer unable to lay out the class, right? As we know, artificial neural network adding to convolution layer. Yeah. Now we will talk about the dropout layer. Generally, when all features are connected to the fully connected layer, data set can cause overfitting during training. So, because of that, overfitting occurs while any particular data works excellently on the training data, producing a negative consequences in the model's performance when used in a new data. So, means the training data is overloading, we can say. So, for reducing this, for to overcome this overfitting problem, dropout layer will play uh, the central, we can say. It comes in the picture. While dropping little bit neurons from the neural network during training data, we get resultant as reduced parameter. Dropout itself explaining, drop means we are dropping something, like someone dropped their ears for getting the better college, for doing practice, or for some family reason people drop. So here also in this artificial intelligence era, or we can say in convolution neural network, the report layer doing the things which is kind of the same thing, right? So yellow layers you're seeing, there's some red layers added, you know, drops, we are dropping the neurons so that we will get the desirable output. Because you have understood the basic concept of CNN, how it is working. So finally we reach to the last layer, said to be ReLU, which comes under the activation function. So the question arises in my mind, what is ReLU layer? Actually, it comes under the activation function in deep learning models. Most of the time we use ReLU layer because it is which is compatible with the complex neural network. Now let's come to the definition. ReLU stands for Rectified Linear Unit, which used to increase the intricacy of the neural network via initiating non-linearity. Due to this, it authorized the network to acquire more intricate representation of our data. For example, as you are seeing in the graph, this line comes from 0 in x direction. After same point, after some point having slope shape, so the formula is f of x is equal to max 0 to x. According to formula, it shows both ReLU function and its derivative are monotonic, which means it never decreases or never increases. This function f of x returns 0 if there is a condition. If input is equal to negative value, else it will return 0. A same value means they're having two conditions like in Python, if else condition. If there's a negative value, then it will return 0, otherwise it will give the positive value which we have given in the input. So like that it is happening here. So same value back. So the question arises, why we are using ReLU? So answer is, it doesn't allow to activate all the neurons at the same time. Because let us suppose if any input is negative, then ReLU transfigure it to simply 0 and prohibit the neuron to get activated, making the network easy for computation. Now let's take one example. If x is equal to minus 10, so function is f of x is equal to max 0 to x. So it will take maximum value from the function. So function having two values. First one is 0 and second one is minus 10. So obvious it will take 0. But we have another value like 3. So according to mathematical formula, to go along with the maximum term, so it returned 3. Great. So from here is drawback, or we can say limitation. It will not acquire a knowledge of negative value such nearer to s function that is 0 or positive, right? One more question arises in my mind, where we actually applies ReLU or other activation function. Knowledge. It applies after each convolution layer. We have to apply nonlinear activation function. Like we can say, we can use ReLU, leaky ReLU, variance, or other activation function. It is convex function. Now, from here you can completely understand how it is working, right? As you're saying, there's an input layer. You can see it as a color. There's 111 here in the first row, in the second row, in the third row. You're seeing further. We have added convolution and pooling layer, and then hidden layer classification, and we will get output. So basically what it is, this is a circle. Don't look at the output, just listen carefully. This is the bigger circle, and after implementing convolution, pooling, or other activation functions, we are getting the lesser, right? I mean, which it is, and it is also compressed the size of the real input, right? Downsampling it. So here we can say higher dimensionality and then lower dimensionality, and then output it is circle, right? So I hope you understand. It is downsampling and then classification, then we'll get circle. Very easy, I mean, after studying this, I'm not saying it is easy, it is very complicated. But the thing is how we can make the complex thing in easier way. So great. Now we can understand it in better way, that it is how it is showing it, right? So now I can say we are ready to do codings because you have understood the basic concept of CNN, how it is working, right? So finally we have completed all the layers in detail. I hope you understood. So as you're seeing in the picture, this is a Stanford image. I just edited the car image. Input I have just edited. That output and that thing is from Stanford University research. So it is showing that the convolution, then ReLU, then pooling layer they have added. Forgetting there is a higher probability of car, then truck, and the airplane, then ship and the horse, right? So now you are ready to do coding, I can say, or to explain the convolution layer, neural network, how it is working, right? The architecture of what we have used, that how many layers we have, the activation function, the ReLU we have used here, or I can say pooling layer, dropout layer, what we have taken,